Hi friends, welcome to GMK Tutorials. I am very happy to share you guys. We started digital image processing classes also. So myself Jitesh. So let's move on to the topic. In case if you are not subscribing our channel, please subscribe our channel and watch the video till the end because of so many important points will be discussed in the middle of the class also. Okay, so don't miss. Let's move on to the topic. So let us see why image processing. Just if you cover this one slide, obviously this almost covers the one unit in our syllabus also. Before entering into the digital image processing concept, first of all, what is meant by image? Why image processing we are using? What are the different fields of image processing? And what is meant by image sensing and acquisition? How can we represent the image representation? Image modeling and sampling and quantization concepts, basic relationship between pixels and what is meant by pixel, mathematical operations on the image processing. If you are all cover these concepts in the slide, now your first unit may be over according to your Academy of the corresponding university concept. Let's move on to the first one. What is meant by image? A image is a two-dimensional function, like if you are taking as a function f of x comma y, where and x comma y are generally represents the spatial coordinates, and amplitude of f at any point is depends on the corresponding coordinates. Okay, that amplitude generally represents the intensity or a gray level of that image is generally called as a pixel also, right? So when x and y and x comma y and amplitude values of f are all finite, then we can say that it is a discrete quantities. We can call that image is a discrete image or a digital image, right? The field of analyzing the digital image processing refers to the processing of a digital images by means of a digital computer. Then we will can call as a digital signal processing. Okay, that means the digital image processing refers to the processing of images. What kind of images? That images are some finite value. That means the amplitude of that images are maybe some finite according to the corresponding x comma y spatial coordinates. So we can call it as a discrete quantities. Then we can call that images as a digital images. That digital images can be analyzed by means of a digital computers. We can call it is a digital image processing. Digital image processing is composed of a finite number of elements such as particular location and particular value. That is nothing but each and every two-dimensional function represents some amplitude. That amplitude is based on the corresponding spatial coordinate location. That amplitude or that these elements we can call as that finite elements. That finite elements are refers to the picture elements, image elements, pels, and also we can call as the pixels also. The pixel is one of the most widely used element in the digital image processing throughout the concepts, right? So pixel means that it is one of the element in the image that represents which has a particular location and value. Okay, that location can be decided by the corresponding coordinates value. A value means that amplitude of the corresponding two-dimensional function. That amplitude is also we can call as a gray value or maybe intensity at that image, right? I hope the image it is very clear for you, I think. So coming to the next one, why image processing? Okay, why we are using the image processing? The reasons for why we are using the image processing is are following: improve the pictorial information for a human perception. In case if you want to see the image in the better way, we can improve the quality of the image by means of the digital image processing techniques. In that first one is nothing but noise filtering. In case if you are taking any image, obviously that consisting of some noise due to the corresponding capturing time, or motion noise, or maybe salt and pepper noise, or like this. If you want to remove that noise by means of a digital image processing, we need to follow some of the filtering operations to eliminate the corresponding noise in the image. Second one is nothing but contrast enhancement. If the quality of the image may be decreasing, we can improve the contrast of the corresponding image. It may be appear very better clarity. Deblurring, blurring of the images also can be removed. Remote sensing applications like autonomous mission applications, like remote sensing application, like most of the applications are we are going to use nowadays also. Autonomous mission applications like quality control, efficient storage. So these are, as well as examples is nothing but storage and video transmission applications. These are the different reasons why we are using image processing. Okay, coming to the next one. So before entering into the applications point of view, let us see what are the different types of images. So for the time being, just I will discussing only two mostly used images. That is nothing but a color image. Okay, so let us see the color image. This is a just I will take the example from the resources. Just this is nothing but a, like a salt and this is nothing but pepper. Peppers and tomatoes are all vegetables images will be there. This is represented in the color images. This is the original. So this is nothing but a color image. We can consisting of a generally the color image consisting of a three major components: red, green, and blue. So the remaining colors can be, we can also call it some pseudo colors will be there. Pseudo colors are coming by mixing of the primary colors that is forming like cyan, yellow, magenta, like right. So let us see the next one. Grayscale image. So grayscale images are called, we can call as a black and white image generally. So this is a representation as a grayscale image. So whatever the white places represents the grayscale image maximum value is generally 255. Okay, grayscale image maximum value is 255. If you are zooming like this, the grayscale image quantity is nothing but 255. As well as a complete black point or a black place represents a zero value. In between zero and white, obviously the in between the remaining colors are in shaded colors. Shaded colors of gray, shaded colors. So obviously black to white in between, obviously it is in the form of a light shaded colors. So we can call it is a grayscale image. Grayscale means that it is the shaded colors of black and white. So that's why we can call as a grayscale image. So in the grayscale image, the total pixels range is 0 to 255. 0 represents the black value, white represents the white represents the 255. Okay, that is the in the remaining that represents a correspond. Suppose if you want to see this image, obviously these images can be represented in the form of a matrices actually. Each and color image or grayscale image, each and everything can be represented in the form of a matrix notation only. So let us see the how can you represent the corresponding matrix format. So this is a matrix representation. If you are seeing the image, it can be appearing like this. Just I will resize and after applying this one, I will get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it may be 11 by 11 image. Okay. So these are the some of the pixels which represents the corresponding image values. So these 47 and all called as a pixels. Okay, each and every location. If you are taking 47 is the location of 0 comma 0. 0 comma 0 means that 0 represents a 0 column and 0 row, 0 1, 0 row, first column. So these each and every value that represents a corresponding quantity, corresponding location. These quantities are represents the amplitude or intensity of the corresponding image, whatever we taken for the example consideration, right? So coming to the next one, fields of uses of image processing, like we can call as the application fields of the image processing. So let us see what are the different applications. So coming to this one, these are the numerous applications will be there. Just we will discuss only particular range only. Remaining so many applications will be there apart from this one also. So these are some of the major applications we will consider. So first one is nothing but gamma ray imaging. Gamma rays applications also we can use the image processing. So these gamma ray imaging means these are used in the nuclear medicine and astronomical observations. In a nuclear medicine, inject a radioisotope inside the patient that emit the gamma rays at decays. So as well as if the gamma rays are detected, obviously that can be detected with the help of a gamma rays detection detector. As well as images are produced from the gamma rays that can be detected from the gamma rays detector. Those kind of the images can be analyzed, gamma rays images can be analyzed by means of the digital image processing tools only. Okay. Let's see how the gamma ray image will be appearing. So this is one of the example I will take for the textbook. It is appearing like a gamma ray image. Okay, it is like this. So next one is nothing but X-ray images. Generally, each and every person nowadays we are taking. If you have any injuries, will be takes place in your body. Obviously, we will go for the hospital. Just we will take the X-ray. So that X-ray represents the what is the internal part conditions of the corresponding bones and all those things that can be represented in the form of some film, like it's like a photo black and white negative format will be there. So how it can be generated? Generally, I think most of the cases we observe that X-ray source will be there and as well as some film detector will be there. So in between that, we can place the corresponding patient. We can inject the we can emit the corresponding gamma rays, gamma source of electrons from the X-ray tube or vacuum tube. Obviously, that rays can be passing through the corresponding body. That electrons are strike the film sensitive X-ray radiation that will be represents the corresponding image in the corresponding film. So that is nothing but one of the application of the X-ray imaging. So let us see generally. So it is used in the medical field and also used in the industry and astronomy applications. X-rays for the medical and industrial applications are generated by the X-ray tube, which is nothing but a vacuum tube with a cathode and electrode. Okay, then only it is possible to emit the electrons, right? So cathode generated electrons, when it strikes the nucleus, it is generated the energy in the form of a X-ray radiation. The images are generated placing a patient in between the X-ray source and film sensitive to the X-ray radiation. Right? So this is a real-time application. I think most of the cases we observe this one. Okay. So let us say this is a X-ray. This is the just of the corresponding body person. So these are all the some of the X-ray images. I will take the this picture from the textbook. Okay, Gonzalez textbook, I think. Okay. So thank you, sir, for providing a resource for me. For this is nothing but sharing of the information for this one only. So coming to the next one, imaging in ultraviolet band. So ultraviolet band, I think this is also a very familiar field in the real-time applications. It is used in most of the applications of the ultraviolet in the like lithography applications, the chip designing, like industrial inspection, microscopy applications, lasers, biological imaging, and astronomical application. We are all using these kind of the ultraviolet band for the imaging, analyzing the corresponding images. Let us see the how this image is going to be appearing. This is a ultraviolet image application, and this is a image of the corresponding UV band, right? So next one is nothing but visible and infrared bands. The infrared band often is used in conjunction with the visible band application. It is not separately used, just we can use the corresponding visible band. So the applications of these visible band applications like light microscopy applications, astronomy, remote sensing, industry and law enforcement applications, we are using this kind of the visible and infrared images. Okay. So next one, microwave band. So I think all of you having familiar with this microwave band. Just we are seeing so many applications and like so many so many metals detected in the earth like that conditions were preferred this one, right? So one of the advantage of this image microwave band is nothing but it is also used in the radar application. It is also ability to collect the data at different regions regardless of the ambient whatever the conditions of the environment. So the microwave bands are it collects the corresponding data, so that's why it can be used in many applications to collect the data from the resources. So, imaging and radio band applications is nothing but we are using in so many applications like generally, we preferred MRI images. MRI applications also we are using this radio band application. In case of the MRI band, just we can use the MRI rays from the corresponding mission through the corresponding his body, and that will be detected in the form of a computer, right? So these are the some of the applications of the image processing areas. So not only this one, so many applications will be there apart from this one, like automatic number plate recognition, like so many applications like heartbeat conditions or ECG applications we are also using to detect the patient heart condition. Okay, brain, MRA, like a brain identification, like how the person brain will be there. So that image point analysis is also we are using the image processing application. So many security applications in order to identify the corresponding vehicles in the traffic light condition. That images can be taken by the camera that can be analyzed with the help of a digital image processing tools, and we can analyze the corresponding situation and weather report environment, how the corresponding cyclones pictures and all those things can be analyzed in the image processing. Moreover, signal processing applications, if you want to identify the corresponding signals without any noise in the systems like TDM, TDM applications, FTM applications, that is also analyzed with the help of a MATLAB. So that is also signal is nothing but a it's a related field to the image processing also. So likewise, we are using so many applications this digital image processing in the real-time application. So thank you for guys watching GMK tutorials. So the remaining concepts will be discussed in the next session. Okay, so follow the GMK tutorials for more videos. Okay, so in the next class we will see the image sensing and image acquisition and remaining all the concepts. So thank you, thanks a lot.